Hello, in this video we'll work through this problem here. We're going to complete the following analysis for the graph of the parabolic function y equals negative 2 x squared plus 16 minus 14. So the first thing I want to do is, I'm actually going to do a little add-on to this question, is I'm going to change the form and identify the transformations that are being applied. So if we take this question over here, we have y equals negative 2x squared plus 16x minus 14. Now I don't need to actually go through and graph this using transformations. However, if I wanted to, I'd need to read the transformations off this. And to do that, I'd have to change the form to vertex form. So the first step is I factor out the a term from the first two terms. The next step is I find what we call the magic number. And the magic number is going to be this value here divided by 2 squared. So we have negative 8 over 2 squared, which is equal to negative 4 squared. And at this point, often people will say, well, negative 4 squared is 16, so I'll make that 16. But again, a little trick we learned was that we leave this as negative 4 squared minus negative 4 squared. What this means is that when I actually go and complete the square, it's very easy to factor that trinomial. It's going to be x minus 4. We have minus 4 squared, which is 16, and then minus, we have minus 16 minus 14. So we have negative 2, and we expand these brackets, x minus 4 squared. Negative 2 times negative 16 is going to be plus 32 minus 14. So therefore we have negative 2 x minus 4 squared plus 18. Okay, so again, this question doesn't actually ask us to do this, but I'm going to state the transformations that are being applied to this. So if we take a look at this, we can read them from left to right. We always like, when we list our transformations, to list what is the transformation in words and what are we doing mathematically. So this negative sign means there's a reflection across x-axis. What that means is I'm going to take each y value and I will multiply it by negative 1. The second step here is I see this 2 means there's a vertical stretch by 2. So that means what I'm going to do is I'm going to take each y value and multiply it by 2. Since I have x minus 4, I'm going to shift 4, and remember the horizontal lies, so we're going to shift 4 to the right. So that means I'll take each x value and I will add 4. And finally, I'm going to shift 18 up. So I'll take each y value and I will add 18. So now that we have vertex form, and let's just come back over here and let's write this down. Vertex form, which is right there, negative 2 x minus 4 squared plus 18. What this means is the vertex is going to be at 4, 18. We can find the x-intercepts now. So to find the x-intercepts, what we do is we take our quadratic in vertex form and we set it equal to 0. So we end up with 18 is equal to minus 18, pardon me. So I get 9. So I take the square root, so I get plus or minus 3. So therefore, x is equal to 4 plus or minus 3. So x is equal to 7 or 1. So the x-intercepts are going to be 1, 0 and 7, 0, which makes sense because 4 is going to be halfway in between those two values. So direction of opening, it opens up. Y-intercept can always be read off in standard form So by the c value, so it's going to be 0, negative 14. The domain is x is an element of the real. Remember to say it like that every time. The range, to get the range, we simply look at vertex form, and we see this opens down, and it has a maximum at 18, so the range, or y, are all going to be less than or equal to 18. This has a maximum value, 18, and occurs when x is equal to 4. So now I could go through and graph this. I wouldn't typically use transformations for this because of the fact that there's enough information here for me to do a sketch by putting the x-intercepts, the y-intercepts, and then plotting a couple points. One of those points needing to be the vertex. But let's actually go through the transformations to make sure we understand it. Transformations, I start with my parent graph. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. So there's one branch of my parent graph, which is y equals x squared, and I can very quickly draw on the other branch using a symmetry argument. So what we do is we take 1/2 of the parabola, and what we're going to do is we're going to apply the transformation in 2 steps, and then use a symmetry argument to get the other half of the parabola. So the first thing I'm going to do is transformations 1 and 2. So that is, transformation 1 is the reflection across the x-axis, and transformation 2 is the vertical stretch by 2. So we'll take all the y values and multiply them by -2. So notice how they're listed as 2 separate transformations, but really we're just taking the y value and multiplying it by -2. So this is my first process graph. So 0, 0, we get 1, -2, 2, -8, 3, -16, and we see that it goes just like that. And again, I can very quickly get the other side of this parabola by just using a symmetry argument. There we go. Okay? So now I'm going to take a different color. Let's take green. I like green. And we're going to apply the other 2 transformations. So what we're going to do is we'll take each point and we'll add 4 to the x and we'll add 18 to the y. So 0, 0 becomes 4, 18. 1, 2 becomes 5, 16. Sorry, 1, -2 becomes 5, 16. 2, -8 becomes 6. -8 plus 18 is 10. 3, -18 becomes 3 plus 4 is 7, 0. 4, -32 becomes 8. -32 plus 18, I believe, is -14. Yep, I think that's right. So now what I'll do is I'll plot these points. So the point 0, 0 in the end ends up at 1, 2, 3, 4, and 16, which is way up there. Right? And then we have 4, 18, pardon me. Let me restart that. I just did a little bit of reading incorrectly there. There we go. So I'll grab my green here. So 0, 0 maps to 4, 18. 1, 2, 3, 4, 15, 16, 17. So it's actually going to be off the graph here. But we'll just put it in. And what I like to do here, 1, 2, 3, 4, is I'm actually going to dot in the axis of symmetry to help us see this. There we go. Okay? So we have 5, 16. 1, 2, 3, 4, 5, 16, which is there. We have 5, 6, 10, which is here. We have 7, so 4, 5, 6, 7, 0. We have 8, -14, which is down here. So there's the one branch of the transformed parabola, and what I'll do is I'll use a symmetry argument over 1, over 1, over 2, over 2, over 3, over 3, and notice my x-intercepts make sense from what my calculated values were, over 4, over 4. There we go. Oh, let's make sure we can see this. Don't forget to put the arrows on the end for me. Okay. And there we go. So the motivation for this question was the student asked to see an example again where we actually have a reflection, and how would we go through that if we were to graph this using transformations. I chose this question because it's one we've seen, but I really want to stress the point that in this question we don't ask you to graph it using transformations. You have more than enough information here just to graph a couple points, the x and y intercepts, and the vertex to do this. However, in this example I actually went through the transformation process. Really important when you're graphing this, make sure you use the entire graph. And just to wrap up, like I said, when we read the transformations, this -2 actually represents two transformations. It represents a reflection across the x-axis and a vertical stretch. So that means we multiply the y by -1 for the reflection across the x-axis, and we multiply the y by 2 for the vertical stretch. But often what we'll just say is we say multiply y by -2. I hope this video helped.